Let's try to calculate the centroid location for this shape. It's not quite a square. It's not really a semicircle. It's not exactly a triangle. And so this is a complex shape. It's not one of the ones that I gave you a formula for. So the first thing I want to do is divide the shape into more simple shapes. So I can divide this in half right here, and I have a rectangle for this bottom half. I can find the centroid of that. I also, if I put a line right here, I would have a square up here, and I know how to find the centroid of a square. And that would leave me with this little piece right here that is a triangle. And I told you the formula for the centroid of a triangle. Oh, and look, then the PowerPoint split it up differently than I just highlighted. So the next thing we want to do after we break it into these shapes is determine a reference axis so that we kind of putting an origin on it, if you will. We can put it on any one of these corners. And then that way, if I put the origin here, then my centroid would be a negative amount away because that's the negative x direction and a positive y. Or I can put my reference point here, 0, 0 here, and then my centroid locations would be a positive x and a positive y. Or I could locate my reference axis at this corner, and then I would have a positive x for my centroid location, but I would have a negative y. So I'm going to choose to put my reference point right down here. That way I can keep my x's and y's both positive. We want to stay positive. Okay, so before we go on and find this complex shape, centroid, let's remember how do we find the area of these simple shapes. We're going to need to know area. So the area of a square is just the side of this, the length of the side squared. The area of a rectangle is going to be the base times the height, or the width times the height. For the area of a circle, this is where we have pi r squared. And for the length of, or I'm sorry, for the area of the triangle, it is the length, or the base times the height, and we're going to divide it by 2 because it's half of a rectangle. So take a second and write these down. If you do not remember these from geometry, we're going to need them here in just a minute. Calculate the area of each simple shape. So I'm going to start here. Here's my reference point. And I'm going to calculate the area of this rectangle. So my that's base times height. So my base is 3. And my height is 6. So 3 times 6 is 18 inches squared. For shape number 2, labeled right here with a 2, it's a triangle. So it's going to be the base, which is 3, times the height, which is also 3. 3 times 3. And then we need to divide it by 2. So half the base times the height is half of 9, which is 4.5 inches squared for the area of this piece. And then let's find the area of shape number 3. 3 is a square, so that's just base times height, or side squared. So 3 times 3 is 9 inches squared, so the area of this space is 9. So the centroid location for shape number 1, it's just a rectangle, and if you'll remember from the formulas I just gave you earlier, the x direction is going to be half of the base, so it's going to be 3 divided by 2, and the y direction is also going to be the height divided by 2, so 6 divided by 2. Where these two lines of symmetry intersect. So that's going to be at 1.5 and 3. For the triangle, we're going to do 1/3 of the base, and we're going to do 1/3 of the height. And then our location for the square and shape number 3 is going to be half of the base and half of the height again. So let's determine the distance from each simple shape centroid to our axis that we set up, our reference point here. So how far from here to here? From our axis to here, we need to figure out how far that is. It's halfway of this amount right here. So it's going to be half of 3. This one is going to be half of 3 here, but I also have these 3, so it's going to be 3 for this amount plus 1.5 here. So that'll be 4.5 here. And then this one will be, oh wait, no, this is a third, I'm sorry. If this is 3, then this is at 1. So this will be 3 here, and then we're going to add 1 more, so it'll be 4 here. This one is half of 3, which is 1.5 for the distance from here to here on the square, but then I also have these 3 inches to get back to the reference point. So now let's talk about in the y direction. How far is it from the x-axis to the centroid? It's going to be half of this side right here, and this side is 6. So this is going to be half of 6, which is 3. For shape number 2, it's going to be these 3 plus a third of how it's 3 tall. A third of 3 is 1. So 1 plus 3 is 4. And then for this one, it's going to be half of this side over here. So half of 3 is 1.5. Now, for our formula, we want to take each simple shape's area, which we have already calculated, and we want to multiply it by the distance from the reference axis to the centroid. So the area of shape number 1 was 18 inches squared. The distance from for the x-coordinate in the x direction from the reference axis to the centroid is 1.5. So I'm going to add it there. And then I'm going to multiply 18 by 1.5, and I get 27. Now for shape 2. The area that we calculated earlier was 4.5. And then the distance from the centroid to the axis in the x direction is 4. And I'm going to multiply 4.5 by 4. And I'm going to get 18. And then for shape number 3, I'm going to multiply the area of shape number 3, and 3 is 9 inches squared for the area. And then I want to multiply how far the centroid is in the x direction away from my reference axis. So it is 4.5 away. So I'll put that here. And 9 times 4.5 is 40.5 inches cubed. This is only for the x direction. We're going to have to repeat this here in a minute in the y direction. Same areas, the shapes have not changed size, so same exact areas. Only now I'm interested in how far is it in the y direction. So shape number 1, how far to the centroid in the y direction? The answer is 3. For shape number 2, how far is the centroid from the reference axis in the y direction? So the answer here is 4. And then we're going to multiply, sorry about that, 18 times 3 is 54. And then 4.5 times 4 is 18. Now we're going to multiply 9 times how far it is in the y direction for shape number 3, which is 1.5. And then I multiply 9 times 1.5, and I get 13.5. Now, what the formula says, this little E looking thing here is the Greek capital letter for sigma. This stands sigma, and in mathematics we use this symbol to mean summation or to add up. So I want to take the values I got when I multiplied the area by the centroid location in the x direction. I found all of those. Here they are. Now all I want to do is add these up. And then same thing for the y's. I want to do sigma is a summation notation. So I want to sum all of my areas times the distance they were from the centroid in the y direction. So we found those. And so now I'm going to add all of those up. And the final part of the equation for finding the centroid of a complex shape is then we have to divide the simple shape. We want to find the sum of all the areas. So taking the areas from the first column of our calculations, I want to add all of those up, and I get 31.5. So I'm going to take my sum of my areas times my x's, which is 85.5, and I want to divide by the sum of my area. And that will give me my centroid location. I should go over 2.71 in the x direction. So for y, I'm going to take the sum of my areas times the y's, 85.5, and divide it by the sum of my total areas. And when I divide those, I get 2.71. So from 0, I'm going to go up 2.71. So does this shape have any lines of symmetry to you? Do you notice any lines of symmetry here? This definitely is not one because of this piece right here. But I think that you should notice that, yes, definitely there is one line of symmetry that goes down the middle here. And notice that the centroid lies on it. There's another way to solve the same problem. Our previous method broke it down into smaller parts, and then we added them all up to get the more complex part. But what if we chose to use the subtractive method, and I'm going to use the same exact equations and almost the same exact process, only I'm going to make the object bigger than what it is, a bigger, simpler shape than what it is right now, and I'm going to take out the parts that I don't need, or the negative areas. When you use negative areas, essentially what you're doing, there's no such thing really as a negative area, but essentially what you're doing is telling your summation that you are subtracting those values instead of adding. So let's look at the same shape. We already know what the centroid is because we just calculated it. But what if we did it with the subtractive method? I'd like to show you that you get the same exact thing. So let's start with the shape that's bigger. Let's close this off and make it a square and start with just a square. Oh, and we have to put our reference angles in. I'm going to reference from this corner again still. And then the square, the whole thing, is going to be my shape number 1. And then I'm going to remove this triangular area right here to get the centroid of my complex shape. So I'm going to find the centroid of the whole square, shape 1. And then I'm going to take away from it the centroid of this triangle, which we'll call shape 2. So let's calculate the area of shape 1, the whole square. So it is 6 by 6, so the area will be 36 inches squared. And then let's calculate the area of my shape number 2. It's a triangle, so it's going to be base times height, 3 times 3, and then we're going to divide by 2. Since we are going to remove this area here, I'm going to label it with a negative sign, so that makes my addition problem, which is summation, subtract this value. So I'm going to subtract a negative 4, or it is a negative 4.5, and again the negative because I want to take this area away. So let's determine the shape of the centroid location for shape number 1, which is the whole square right here. So for a square, you do half of the base, so I need to come over 3. It's going to be right in here. And then you do half of the height, so it's going to be up 3, right in here. And where those two crisscross, that's where the centroid will be located. Now let's find the centroid for the second shape. It's a triangle, so the triangle is a third of the base from here. And, sorry, my bad, I clicked on accident. From here, it's going to be from the right angle, it's a third of the base and a third of the height. So let's determine the distance from each simple shape centroid to the reference axis. And I'm going to put my reference axis right here and right here. So I need to know how far it is across here. So it's going to be half of this base, which is 3. And then this one right here is this distance over here is a third of this base, so a third of 3 is 1 from here to here. But my reference axis, sorry about that, my reference axis is over here, so my distance needs to come this way. So if this much over here is 1 and the whole thing is 6, then this over here is 5. So coming up to the centroid here, it's going to be half of the height, so half of 6 is 3. And here it's going to be from the right angle, it's going to be a third of the height. So that's going to be 1 here. So if this distance right here is 1, then the distance from here down is going to be 5. So now we have to multiply the area of the shape times its distance from the centroid to the reference axis. So the area of shape number 1 is 6 times 6, which was 36 inches squared. The x direction for area 1, in the x direction, it is 3. I'm going to multiply 36 times 3, and I get 108. Then the area of the triangle, base times height divided by 2, is going to be 4.5. Again, we have negative because I want to take that area away. And then the distance from the reference axis to the centroid is 5. I'm going to multiply those two, and there's my amount. Now let's do it for the y's. So same areas, they have not changed shape or size. But now I need to know the distance in the y direction. So for shape number 1, how far it is in the y direction is 3. And I multiply these two, and I get 108. And then in the y direction here, for shape number 2, which is the triangle, it's going to be 5. And then do 5 times negative 4.5. So now let's plug it into our formula. We need to sum the areas times the x's. So that was these two. We have them added here, but your area was negative, so we get 85.5. We've seen that number before. And then here, when we do it for the y's, the sum of the areas times the y's. So here's my two areas times y's. I need to sum them. But again, this is negative because we wanted to take it away. And when I do that, I get 85.5. And then we need to sum the individual total areas. So the area of shape 1 was 36 inches squared. The area of shape 2 is a negative 4.5. And so we're going, because we wanted to take that area away, that's why it's negative. I'm going to add those, and I get 31.5. And again, we've seen that number before. So now I want to take this sum of the a times x's, and I want to divide it by the sum of the a, the sum of the area. And when I divide, I get 2.71. And then I need to do the sum of a times y. I get 85.5. And I need to divide by the area, 31.5. And again, I get 2.71. 2.71 in the x direction and 2.71 in the y direction. And so that's where my two lines meet, and that's where the centroid is. Okay, and again, it still lines right in the line of symmetry. What would happen is if we cut out this shape with these dimensions, and I measured this out, and I put my finger right here on this shape, I could hold it up in the air and it would balance perfectly. And so that's what we mean by centroid, or center of mass. So here's those complicated formulas again, and we broke it down into smaller parts to make it more manageable. So we did the sum of the x direction centroid times the area. All of those, the sum of all of those divided by the sum of the areas. Then if you want it in the y direction, you simply use the y distance from the centroid to the reference axis times the area. And we're going to add all of those up, and then we're going to divide by the total area. And then should you be doing this in 3 dimensions, you'll often have a z point for your centroid. And so it's the same exact idea, only now you'll use the distance from the z-axis times the area. So take a second and make sure that you have these written down.